Question number 11. One of the reactions in the rechargeable lead acid battery is shown. Which statement about this reaction is correct? So we can see. So first we can calculate the oxidation numbers, and then we have to actually decide which statement is correct or wrong. Let's see then. So here lead is 0, and over here lead is, so oxygen has valency of -2, so -2 into 2 is -4, so lead will be +4 to balance the -4 of oxygen, the two atoms of oxygen. Then over here, since all are talking about lead, we will only calculate the compounds or elements that have lead, that are lead or contain lead. So lead sulfate here, 4 molecules, 4 oxygens, so like it will be -2 into 4, and sulfur is also -2, so this lead should be minus, no, not actually minus, it's 8 plus 2, and so the oxidation state of lead here should be 10. We can see it is oxidized only. There are no other compounds with lead, and so these two are wrong. And it is not reduced, even it increases from 0 to +10 or +4 to +10. So it should be only C, because I cannot see any other lead compound, and no other lead compound, so it is just oxidation. Lead is oxidized, right? That's correct. Okay, KMnO4, number 12. KMnO4 is an oxidizing agent. Its reaction with Fe2 plus is shown in the following ionic reaction. So we can see a few ions over here. First, write the equations for those ions. So the first one is MnO4 minus plus H plus. So this is one reaction that we need to know, and it's mainly from our theory. So MnO4 minus, okay, that then plus H2O. Now the thing that we have to see here is the number of oxygens here is 4, so this will have to be balanced by 4. Since that is done, then we have to then place 4, so there are 8 hydrogens here, so we'll put an 8 there. Now we have to also balance the electrons so that we can multiply the number of electrons with this ion. So first, let's see this. So the valency of manganate over here is so -1 plus 4 into 2, which is +7, and it decreases to +2, right? +7 to +2, so it has gained 5 electrons, so we have balanced that. Afterwards, we have another ion which is losing electron, but this time, since we have to make it 5 electrons as well, we'll multiply this equation by a 5 and make it 5 Fe2 plus minus 5 electron to form 5 Fe3 plus. So those are the equations. So what are the values of x and y is what they're asking when the equation is balanced. So x is 1, of course, okay, but because we did not have to balance anything here, so x is 1, so answer will be among the first 3, and y is this one. So Fe3 plus is 5 molecules or 5 moles, so this is the only 5 that I can see, so answer should be C. This is a good question. Okay, question 30. Nitrogen or hydrogen are mixed in a reaction vessel. The reaction reaches equilibrium giving a mixture of nitrogen, hydrogen and ammonia gases. So the equation is given. The number of moles is very important, because while calculating Kp, the number of moles is squared, it goes to the power, or is cubed. So first we need to find out the mole fractions. So let's find out the n for this. I'm showing the calculation in one of them, and you can just get the idea for the others. So it's the number of mole for one gas by the total number of moles, means the addition of this 3, right? Addition of this 3. So it's 180 plus 590 plus 160. This is all the theoretical thing you have to know. So 180 by 590 plus 160, the mole fraction is 0.194. I'm just going to do it in the calculator now, because I've shown the calculation for once. I hope you can understand how I did it. This one is 0.634. For this one, n is 160 by 590 plus 180 plus 160, 0.172. So that is the mole fractions. Now we need to find, this is the I need to find the Kp. So we need to now, oh right, we have been given the total pressure here, so we'll now use the partial pressures and then calculate Kp. So let's do it directly. So for nitrogen is 0.914, and we will multiply it by the total pressure to find the partial pressure for nitrogen. I'm not doing the separate calculation, I'm just multiplying it directly. And of course, since it has 2 moles, it will be squared. Then for hydrogen, it's 0.634 into 300, and this time 3 moles, so it will be cubed into finally 300 into only 1 mole. Oops, sorry, I've done one mistake actually, one small mistake. So this one was mainly, this one was for ammonia, 172, and this one is the one for nitrogen, this time 634. So now I'll just place this in the calculator. You guys can do it as well. See if the answer comes. 634 into 300 whole cube. Mm, 300 into 0.634. 300. What is the mistake? Oh my god, what am I even doing? It's 0.192. Okay, 192, this should come. So it comes 0.172 into 300. 0.634, 300 whole cubed, 194. Something is definitely wrong with me, definitely, because this is 194. I'm so sorry guys, 194. So it comes 6.65 into 10 to the power minus 6. So answer should be A. So I'm really sorry, just messed up a few values. Okay, question 14. Let's rush again. A mixture of hydrogen gas and iron gas is placed in a reaction vessel of volume V at temperature T. The reaction is given is allowed to come to equilibrium. All substances remain in gaseous state. Argon gas is pumped. First thing, argon isn't present here, and so no effect of argon, and temperature is same, so no effect on rate. So rate and partial pressure of HI at equilibrium affected. So the rate is unaffected, so answer is between C and D. And okay, the partial pressure of equilibrium. So partial pressures are affected by increase or decreases in product, and since AR isn't present, as I just told here, no change in product, hence answer should be D. 2 experiments are carried out to study the reaction between zinc and sulfuric acid. So experiment 1, small lumps of zinc are added to excess dilute sulfuric acid. Experiment 2, the reaction is carried out at lower temperature and with one another change. Temperature is lowered, and for that one, excess dilute sulfuric acid, small lumps. Both experiments produce the same total volume of gas and are completed in the same time. So rate same, So we can't add anything that affects the yield of the reaction. So we can't add anything that affects the yield of the reaction. So a catalyst is added definitely. There's no effect on yield, and it will help maintain the rate because the temperature is lowered, so it will help maintain the rate. So this can be an option. A greater mass, as I told, we cannot increase the yield. A greater volume again will increase the yield. Larger lumps are used, so this reduces rate as surface area decrease. So that is also wrong because rate has to be maintained. Answer is hence A. This is a good question as well. Question number 16. The relative magnitude of the property X of 5 elements is shown. P, Q, R, S, T are all in period 3. So it's talking about the properties of period 3 and have consecutive atomic numbers. I hope this graph is very familiar. Theory. This is purely from the theory. This graph has to, you need to know the shape of the graph. Shape, and it's better to know like which one is what, right? So yes, and also know the descriptions of why property description of why the property changes. In this case, X is electrical conductivity. It is electrical conductivity. Descriptions of why property changes, and here it is electrical conductivity. So this is just from the theoretical knowledge, so it should be already A. And also you can see that this is Al3 plus, and right, so that's how it works. So it's aluminium. So the elimination actually comes up in the very first part when you know what the property is and what the shape is about. So try to remember the shape of this type of graphs. These are given clearly in the Cambridge endorsed books or any type of resources online. You can just try out any. Question 17. Element X is in period 3. Element X reacts with oxygen, so it's X plus O2 to form something to produce solid Y. Okay, this something is Y in this case. In this case it is Y. When solid Y is added to water, then this Y is added to water to give solution of pH less than 7. So element X, if element X is sodium and is added to water, so sodium oxide. Now when you add sodium oxide to water, it gives pH 10. So that is wrong. Again, this is of the period 3 topic that we have in our syllabus, so you just got to see that. Then we have silicon. So silicon gives silicon dioxide, and this is insoluble in water, right? Then we have phosphorus. Phosphorus either gives P2O5 or P4O10, and this gives H3PO4, which is pH less than 7, which is acidic. So answer should be C. And this one gives you sulfur dioxide, and this is a gas, so not solid. So I hope that makes sense, that description. I've explained why the others are wrong and what the products they're giving. So that is about question 17 question. Okay, this question refers to isolated gases species. Question 18. The species this are isoelectronic. This means they have the same number of electrons. I think some terms which you will learn from the past paper, like isoelectronic, if you have to read this extra line, it takes up that extra 5 seconds, 10 seconds, which you don't want to waste. In which order do the radii increase? So when positive ion, more attraction, so radii is smaller, so it should start with Na plus, and by our periodic table here we know that the Na plus, this is 10 electron, and neon is also 10 electron, but since the positive ion has more attraction, so the radii is smaller, so we'll start with Na plus. Okay, F minus will, fluoride ion will have the highest because minus Ve, less attraction. So radii is increased or larger, so that will be at the very last. Okay, so that's only one option, which is C. Separate samples of magnesium and calcium are added to an excess of dilute sulfuric acid. The observations are summarized in the table. We'll keep the periodic table with ourselves. Okay, metal, magnesium. Which statement explains the difference in these observations? Let's see the observations first. Vigorous reaction, bubbles of gas produce, magnesium completely dissolves. This is about solubility. And rigorous reaction. Both are vigorous reactions actually. Bubbles of gas produce, same thing. Reaction soon stops, leaves. Okay, so this is less soluble. So okay, so we will talk about solubility. So the only option with solubility is this, and if you look at the trend of your group 2, solubility decreases down the group of sulfates. So this metal sulfates solubility decrease down the group. Answer should be D. Quite easy, that one. This is just like the basic theoretical knowledge that we have to know, right? Dolomite. Okay, question 2. Dolomite is a double carbonate, CaMg carbonate, 2 molecules of carbonate ion, and can be used instead of calcium carbonate for treating acids. So this has 2 carbonates, this has 1 carbonate. The three statements all refer to the agricultural use of this carbonates. Alright, agricultural use. Dolomite and calcium carbonate are both less, not really, because carbonates are less soluble than any sort of hydroxides or any type of substances that are nitrates, that is nitrate salts. So that is wrong. Number 1. Carbonate is less soluble, so it is rather right. So this is correct. 1 mole of dolomite has the same neutralizing effect as 1 mole of calcium carbonate. Not really, because neutralizing effect here depends on the number of carbonate ions present, and dolomite has 2, so more neutralizing effect, but calcium carbonate has just 1, as I've just given here, so less neutralizing effect, so that is wrong. Dolomite, okay, so let's just eliminate option 2. We should already be with B. Let's explain 3 still. Dolomite and calcium carbonate both increase the ES, because when they go into the soil, carbonate ion forms CO2, and CO2 is acidic. Hence, that is correct, and that is the reason why only options 1 and 3 are correct.